This is section 7.2, solve linear systems by substitution. So, to solve using substitution, this is totally algebraic, so we're not graphing anymore. We're just looking at the equations. So first you have to solve one of the equations for one of its variables. So this is going to be easiest when one of the variables has a coefficient of 1 or -1. Once you solve it for one of the variables, you're going to substitute the expression from step 1 into the other equation and solve for the other variable. Then once you get your answer, you're going to plug that back in to step 2 and solve. This is going to make a lot more sense when we do it. So, for example, if you have the system of equations y equals 2x plus 5 and 3x plus y equals 10, well, the first step's already done for us because the first equation is already solved for y. So what we're going to do is we're going to take 2x plus 5 and plug it into the second equation where you see y, because y is equal to that. So 3x plus 2x plus 5 equals 10. And now it's just like when we used to solve equations. We have to combine like terms first. So 3x plus 2x is 5x plus 5 equals 10. And now to get x by itself, I need to subtract 5 from both sides. 5x equals 5, divided by 5, and x equals 1. So remember, the solution to a system is an ordered pair. So now we only have part of the answer. We still need to figure out what y is. But we can take x equals 1, plug it back into the first equation to figure out what y is. So y equals 2 times x plus 5, well, x is 1, so y equals 2 times 1 plus 5, and 2 times 1 is 2, 2 plus 5 is 7. So now, our system of equations, the full solution is 1, 7. So if we were to graph this, their intersection would be at the point 1, 7. So it's just a different way of solving. Alright, here's another example. We have negative 5x minus y equals 12 and 3x minus 5y equals 4. This time, we don't have one of the variables already isolated for us. Notice both the x and the y are together on the left side of the equation in both. So, this is where you sort of have to make a decision. The first equation is going to be easier to isolate the variable because if you look here, that y has a -1 as the coefficient. So that's going to be easier to get by itself. So let's look at negative 5x minus y equals 12. And to get y by itself, I'm actually just going to add y to both sides. So I get negative 5x equals y plus 12. And now I want y totally by itself, so I'm going to subtract 12 from both sides. So negative 5x minus 12 equals y. So now I have what I need because I've isolated the y. And again, I can now look at the second equation, and where I see y, I replace it with 5x minus 12. So over here, 3x minus 5 times negative 5x minus 12 so 3x minus 5 times negative 5x minus 12 equals 4. So now, since we have all x's, we can solve for x. So the first thing we have to do is distribute that negative 5. And don't forget, that means you need to distribute the whole thing, not just the 5. So 3x, negative 5 times negative 5x becomes plus 25x. negative 5 times negative 12 becomes plus 60 equals 4. Now I need to combine like terms, so 25x plus 3x is 28x equals 28x plus 60 equals 4. Subtract 60, and you get 28x equals negative 56. Now if you divide by 28, x equals negative 2. So again, now that I know x, I know part of my solution, but I need to find y. So I'm going to take this, go back to where I isolated y, because that's going to make it easier. And y equals negative 5 times negative 2 minus 12. So y equals negative 5 times negative 2 is 10 minus 12. Y equals negative 2. So my solution is the ordered pair negative 2, negative 2. Or in other words, if I were to graph both of these equations, they would intersect at negative 2, negative 2. Don't forget, you can always check these solutions too. So if you plug them back into both equations, they should make both true. Alright, so here's what I was talking about. For example, if you graph both of those equations, their intersection, again, is that same ordered pair that you're finding algebraically. Okay, and the substitution method is oftentimes what we use with word problems. So just to give you a procedure, when you have a word problem that you need to set up a system for, you need to read the problem very carefully and identify what all of the numbers represent. So you really got to think about what they stand for in that problem. And keep in mind, for a system of equations, you're going to have to write 2 equations from that word problem. Then you need to decide what the variables x and y represent. They must represent the same things in each equation. Then you need to write the 2 equations, and they'll either be in standard form or slope-intercept form, and it's okay if there's one of each. Then you're going to solve the system using substitution. So for example, many businesses pay website hosting companies to store and maintain the computer files that make up their websites. Internet service providers also offer website hosting. The costs for website hosting offered by a website hosting company and an internet service provider are shown in the table. Find the number of months after which the total cost for website hosting will be the same for both companies. So, a big part of system word problems is you're comparing 2 things, sort of trying to decide which is better, or at what point do they become the same. In other words, when do they intersect? So in this case, we're trying to figure out essentially which one would be more worth your money. So would it be cheaper for you to pay a setup fee and pay less per month, or would it be a better deal to not pay a setup fee and pay a little bit more per month? So our input is going to be the number of months that you're paying for this website. Our output is going to be how much it costs us to pay for that website. So essentially we're asking, well, how many months makes it worth my money to just pay the setup fee? So my output y, how much it's going to cost for the first one, is, well, $21.95 per month, x, my month is input, plus the $10 initial setup fee. The other one is just going to be $22.45 per month. So now we need to solve it. Okay, so again we had... Okay, so now we need to solve. Well, this time it's actually convenient because both are written in slope-intercept form, so we can substitute one in for the other. Now, since they're both equal to y, we're actually just going to set them equal to each other. So it's kind of like taking this part, plugging it in for that y. So it becomes 2245x equals 2195x plus 10. To combine like terms, I'm going to move this x over with the other one. So I'm left with 0.5x equals 10. And now divide by 0.5, and x equals 20. Again, that's only part of my solution. So in other words, after 20 months, the cost is going to be equal. So if you plan to run this website longer than 20 months, it's worth your money to go ahead and pay the down payment. But let's figure out what that cost is by plugging x back into our other equation. So x is going to go in there. So my cost, y, is 2245 times 20 months, which equals $449. So in other words, after 20 months, you will have paid $449 no matter which service you use. But after 20 months, it would be cheaper than for this monthly payment because the down payment is gone at that point. You did that at the beginning. And that's it for this section.